want to start today by actually talking a little bit about yesterday and two key points. And the two key points were kind of buried in the notes on the side, in boxes on the side of yesterday's note sheet discovery packet type thing. One was on the first page and one was on the second page. So what I want to talk about is that when you're using the law of cosines, you want to find the largest angle first. Okay? And the reason we want to find the largest angle first is because when we're dealing with inverse cosine, we are restricted, or the restrictions for the law of cosine was up top. So it has to be between 0 and 180 degrees. Okay? Law of cosines will give us an obtuse angle. So that's why we find law of cosines to find the biggest angle first with that rule. Law of sines, or excuse me, when we're using the law of sines, inverse sine restricted it to between negative 90 and 90 degrees. So that's only going to give me an acute angle. Okay? So with that being said, law of sines, we find the smallest angle we can. Okay? Law of cosines, find the biggest angle. Law of sines, smallest angle. So, starting out today, let's warm up with this particular problem. We get an answer? Why not? So the two shorties have to be bigger than the long side, right? Okay? And so in this case, 1 plus 4 has to be bigger than 8, and 5 is not bigger than 8, so we don't get any triangle formed. Okay? Tricky, tricky, tricky. Now, let's say you didn't see that. Okay? So which angle should we solve for first? Solve for angle C first. So that's going to be a C squared equals A squared plus B squared minus 2AB cosine of C type of problem. Well, C squared is 8 squared, that's 64. A squared is 1 squared, that's 1. B squared is 4 squared, that's 16. Minus 2 times A times B is going to be 8 cosine of C. So far so good, no big deals going on here. Subtract 17 from both sides, gives me 47 equals negative 8 cosine of C. Divide by negative 8. 47 divided by negative 8 is equal to the cosine of C. And this number has to be between negative 1 and positive 1. It's not. So when we type it in the calculator, we should have gotten an error, domain error, dimension mismatch type situation. Okay? And then we would have said, oh, no triangle gets formed. Okay? All right. Let's talk baseball. Pitchers and catchers reported a couple of weeks ago. Spring training is in full swing. Okay? Talk about John Lester and his inability to throw the ball to first base. Okay? Pitcher. Used to be for the Cubs. I don't think he re-signed with the Cubs this year, but bless you. Can't throw the ball from the pitcher's rubber to first base. Okay? So, bases on a baseball diamond are 90 feet apart, and the front edge of the pitcher's rubber is 60.5 feet from the back corner of home plate. Find the distance from the center of the front edge of the pitcher's rubber to the far corner of first base. Then find the angle between the segments connecting the pitcher's rubber to first base and the pitcher's rubber to home plate. Okay? So, the 4 bases on a baseball diamond make a square. Yep, they actually make a square.
Why do you call it the diamond?
Oh, let me show you. Okay, so there's my square, right?
A square is a diamond. A diamond is a square. Just like a rectangle is a square, but a square is a rectangle.
Okay, so it becomes a diamond when you put it on its side.
So it's a square.
So it's really a square.
Yeah.
Yep. It's also a rhombus, yes. It's also a rectangle.
That has like a shadow. Do you see that?
What's wrong?
The
Oh yeah, the square's got a little bit of a shadow.
mm-hmm.
Yeah. You see that like right in here?
Yeah.
Yeah. I wonder if I can get rid of that.
Why you don't like it?
No, I don't.
I think it's the projector. Because all the letters have that too.
Oh yeah?
Oh gosh.
Oh, snap.
Bother me
Way to
now.
go. Good job. There, I'm over it. Probably the projector.
I'm not over it.
Alright, so what do we know about a baseball diamond?
It's a square.
It's a square. What else do we know?
4 bases.
4 bases. Okay, so home plate is usually down here. And then you got first base, and you got second base, and you got third base. What else do we know? All the sides are 90.
Pitcher's mound is 60.5 feet from the home plate. I played softball. Oh. No, I'm kidding.
It's
It's
right
in there.
there.
Oh.
I
I like,
played a lot
how
of
did you
softball.
know that?
It's also in the problem.
Yeah, I don't know nothing about
Okay.
it. Valerie, what?
So this is 60.5 feet. Okay. What are we trying to find?
The distance from the pitcher's mound to the far corner of first base.
Okay, so we're trying to find that, right? Let's call it X.
We got side, angle, side.
We have an angle.
45 degrees.
How do we know it's 45 degrees?
Half of 90.
Because it's half a 90. The diagonals of a square bisect the vertex angles. Okay. Good. Can you find me X? Find it. Sorry. I'm redrawing it.
If X is your opposite, then you're adjacent.
What do you mean?
Don't you do like if the opposite's bigger than the adjacent?
Is that a 90 degree
No, that's not that kind of problem.
I don't know. It's not? Okay, so if we don't know, right? It kind of looks that way, but we don't know. So we can't assume that it is, and we can't use SOHCAHTOA. Okay, so what can we do then? Law of cosines, yeah.
Can we have the equations with us, or do we have to memorize?
You gotta memorize it. Yes? Okay. Then it went on to ask, then find the angle between the segments connecting the pitcher's rubber to first base and the pitcher's rubber to home plate. Let's call this angle P here because it's the pitcher's rubber. So we want to find angle P. Right? Now, looks to be right angle. Just found that it wasn't, but could be obtuse. Possibly, yes. Okay, so which angle should we really find first? The other angle. Let's call it angle F here for first base. I already used blue. Okay, so we should find angle F if we're going to use the law of sine. If we wanted to find angle P, what should we use? Law of cosines, because it might be an obtuse angle, and the law of cosines would give us an obtuse angle. Okay? So find me angle P somehow, some way. You didn't get that?
I also forgot.
Hold on.
42.
Hold on, I did 60 instead of 60.5.
42.176.
Times 180 divided by pi. Gets me, this should be 42.176, yes.
Can you not use the law of cosine?
You can. I'll get there in a minute.
Yeah, I still did it wrong. Yeah, I think so. I just don't get why you have to use. I smell like pizza in you. No,
I don't know.
It's making me feel nauseous. Did you actually? You're disgusting. Because maybe you ate a lot of pizza last night.
That's not how it works.
I get 92.824 degrees. What's your question?
Nothing. Got it.
Okay. Who was wondering why we couldn't use law of sines?
No. I just was making sure he. I mixed up.
Okay. Yes, you could use the law of cosines, and it would take you right to there.
That gives
Yes.
you the 90.
But if we would have gone in back in this triangle, let me back this up a little bit. Beep, 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 beep. Back in this triangle, if we would have used these two, so if we would have went law of sines here, and we would have went the sine of angle P over 90 equals the sine of 45 over X, what we just did there, we would have gotten an angle of 87.176 degrees. Okay? Which wouldn't have worked because it would have been wrong. Yeah, because we got to find the smallest angle using the law of sines. Okay? Love it. Oh, yeah.
Regular hexagon. 6 sides.
6 sides, regular hexagon, yes.
1, 2, 3,
Luckily for me,
5, 6, 7. Oh, yours is better than mine. I drew mine out. 1, 2, 3. How do you draw yours? Wings construction. Oh wow. 5, 6.
is it?
Yeah. Each side is 40 feet.
Well, there. That's pretty good,
That's
isn't
how
it?
mine looks.
Okay. So, what do we all know?
Each side's 40.
Oops, tap the brakes. And hexagons aplenty. Still being made. Why is it still making hexagons?
Did you have to check it off?
No, it's on the arrow. Alright. Now it'll stop making hexagons. So if I say that we are at this point right down there, okay, then I've got a diagonal right there.
Oh,
Then I've also got, how do I know how to draw those?
yeah.
Because the definition of a diagonal is connecting any two non-consecutive vertices. So like this, I can't connect this one and that one.
Oh.
That doesn't make a diagonal.
You could go from a different top one, right? Top left.
but I want to be at that one point. So I want all the diagonals off of that point. So my next diagonal, we'll make it be red. Is right there. And then my last one is there. Okay. So what else do we know about our diagram? All the sides here?
Is a stop sign an hexagon?
Nope, that's an octagon. What else do we know? Okay. Nope, that only works with right triangles. What do you mean the degree measures? So green and purple are going to be the same?
Yeah.
Yep, I agree with that. That green and purple are going to be the same because the two triangles are congruent. Okay, what else do we know? Okay, what is it? So you're saying we can figure out the, like, for that angle right there? Okay, how am I going to figure out that angle? It is not 540, that's a pentagon. Nope. $720? How? How is it 720? So there's four triangles, right? Right? So there's four triangles. So we've got 4 times 180 gets me 720 total degrees at the vertices. How many vertices are there? 6. They're all the same. So each vertice would be 120 degrees. Okay. We said purple was equal to green because of those. Can we find X now? Yeah? All right, find it for me. I get 69.282 feet. So that was for purple and for green. Now what? We gotta get red. What else do we know? Kurt?
There's, sorry, the two last angles are 60 on the pentagon. That makes any sense. The angle with Y. Yep, that one to the next 40 is 60.
This one over here? Okay, how?
The sum of the angles on a pentagon are 540, and we have two 120s, the other is 120, and the two angles are
Where are you going with a pentagon?
pentagon, not 5 sides, times 4.
Yeah. That's the downfall. I don't see a pentagon.
Well, we know that full angle is 120.
Okay.
Because it's a regular hexagon. Y
Okay.
press the hexagon vertically in half.
Okay.
Each side has to be 60.
Okay. I would go with that. I would go with that as a logical definition. So that then this angle up here is 60. Okay.
You know that angle between red and purple is 30?
This one down here?
Yeah, because the one below in the bottom right corner is isosceles, so 180 minus 120 divided by 2 would be 30.
So these two are both 30.
Yeah, so then
Okay.
since it divides into 60, that means that red and purple, the angle between that is 30.
Okay.
Divided by 4.
Or the fact that this is 90. Right?
Yeah.
And then since that one was 60, then that one's 30. Okay. So what can we do here now to find y? We could use our 30, 60, 90s, or SOHCAHTOA, or Pythagorean theorem. Yep, we got tons of different stuff that we can use because that red, purple, black triangle here is a 30, 60, 90 triangle. Okay? So if I'm going to find red, I'm going to use one of those, and I'm just going to use Pythagorean theorem just because it's been the most common one so far today. So we get 40 squared plus 69.282 squared. 40 squared is 1600. 69.282 squared is 4800. So then that's going to be 6400, and the square root of 6400 is 80. Questions, comments, concerns, clarifications? If I was quick enough, I could, break it down into a haiku. Okay. I have a worksheet packet for you for the applications of the laws of cosines and the laws of sines. We are switching now to the 85% rule. Okay? So if you are getting higher than an 85%, this homework is now optional to turn in. You should still do it, but it is optional for you to turn in.